So now that we've talked about vectors, we're going to talk about how to add and subtract vectors. So the resultant vector is going to be what you get when you add the vectors together. So for example, I'm adding A plus B plus C, and I'm going to get a resultant vector of R. So when you put them together, you always go tip to tail or tail to tip. So you start here and then you go this way and then you stick the next one on there at the end of the arrow, go to the tip, and move on through. But unfortunately, we can't just cut out arrows every time to add the vectors, so we need a way of doing this mathematically. So if we want to add these two vectors together, I have one vector of a length of or magnitude of 42 at an angle of 16 degrees. And then I have this other vector over here that's 15 long, so that's the length of this arrow at 40 degrees. The first thing that we need to do is we need to find the x and y components of the vectors. So if the whole vector is the hypotenuse, I need to figure out how much is in the x direction and how much is in the y direction. Second, what I'm going to need to do is I'm going to add the vector components. So this x piece of this vector is the component. So when I'm talking about the vector components, this is the x component of this vector. This is the y component of this vector. And so what I'm going to need to do is I'm going to need to add this x piece plus this x piece by itself to get my resulting x direction. And then I want to know how far up I went, so I need to add this plus this, and that's how I'm going to get my resulting y vector. So what that looks like is something like this, where I'm actually adding the two together to get the overall x and the overall y to be able to figure out this new resulting vector in light blue. To get the length of that resulting vector, I'm going to use Pythagorean theorem. So A can be on the bottom, B can be over here. I know I did not write a right triangle, but if we're talking about the x direction and y direction, they necessarily have to be perpendicular to each other. So you don't need to write the perpendicular thingamajobber. You can just leave it as looking like an x and y and just call it good enough. And then you're going to use trigonometry to solve for the angle. So we're going to have to use sine, cosine, or tangent to solve for that angle theta. And I'm going to show you how to decide that. And we're going to do an example. So we're going to add these two vectors. This one is 42 long, that's the magnitude. The angle is 16 degrees above the horizontal. This has a length of 15 or a magnitude of 15, and this is 40 degrees above the horizontal. So the first thing that we're going to need to do is to find how much is going in the x direction and how much is going in the y direction. So to do that, I'm going to use cosine for the x's because it's adjacent to my angle. And cosine is adjacent over hypotenuse. And the y side is the opposite side, so I'm going to use sine. So just remember that we have SOHCAHTOA. And so I know that I need to use cosine for the x direction because if this is my angle, then this is adjacent. So that means I'm going to use adjacent. And the hypotenuse is the number that I have, so I need hypotenuse as well. So that means I'm going to use cosine for that. So if you need more help with the triangle thing, go back to the math videos and take a look at those. So here I'm finding the x component. So I got 40.37. For the y direction, I get 11.53. That's for this vector. And then for the other one, I'm going to do the same thing. So I get 15 times sine of 40 is 9.64. And then this is for that one up here. And that's 11.49. So now I have the x and y components for both of my vectors. And now what I need to do is add those components. I'm going to add the x's together and I'm going to add the y's together. And I want to be really careful not to add an x to a y because they're in different directions. So I want to know the total x and I don't want to know the total y. So here I'm just taking this x and putting it there, and this x and sticking it there, and then the same thing with the y's. The y for the first one goes there, the y for the second one is here. And then all I need to do is add them together, throw that in a calculator or do it in your head. And then once we have that, now we have our total x and our total y. So this is what we figured out for that overall x, and this is what we figured out for our overall y. So once we have that, that's these sides of the triangle. And so that means that now I can use my Pythagorean theorem to solve for my hypotenuse. So using a squared plus b squared equals c squared, I'm able to plug in these numbers here for a and b and solve for c. And so here I'm doing this. And then once I get 3139.75 is equal to c squared, I'm going to square root both sides. And I get 56.03. And so that is the length of this vector. So now I have the magnitude of my vector. Now the other thing that I need to figure out is my angle. And so the angle goes down here in the bottom left. It's usually always relative to the horizontal. Horizontal is this way. And so I find that out by doing trig. So again, I'm going to think about SOHCAHTOA. I have my adjacent, I have my opposite. And so in order to find this, I have tangent of my mystery angle that I don't know yet. And I put that opposite, which is 21.22, divided by adjacent, which is 51.86. I take the inverse tangent of both sides, which cancels out this tangent and puts an inverse tangent over here. And then I get 22.25 degrees. Now, if you need to subtract vectors, it's basically exactly the same, but just flip the arrow around. So if I'm adding a plus b over here, I have a going up and to the right, b going down and to the right. So in this case, I added a plus b where b is going down and to the right. This is going to be if I subtract b, that means it's going in the opposite direction. So these are both b vectors. They just go in the opposite way. So when I add them together, I get this c vector, this blue one. And if I subtract b, I have to move this arrow. It was over here, and I have to move it up there so it matches this. And that's going to give me a different resultant vector, and that is going to be d. So you can see how a plus b is different than a minus b. If you have any questions, let me know.